Hey guys, Mr. Baines here to talk about air pressure. Let's get started. First things first, add this to your table of contents. Go ahead and pause it. All right. The goal is to be able to determine which sections of air have a higher or lower air pressure. You will be able to draw how molecules of air create something called air pressure. First of all, what is air? Write down 3 things you know about air. Go ahead and pause it. All right. So I may have shown this to you before, but matter is composed of protons, neutrons, and electrons. When you put those together, you can make atoms. When you put atoms together, you make molecules. 1 oxygen atom and 2 hydrogen atoms make a water molecule, H2O. Okay. There are millions of water molecules in just 1 droplet of water. And air is also made out of molecules. There are millions and billions of air molecules around you right now. So this is what air is made up of mostly. Now, you already know that we breathe in oxygen, but you may not know we breathe in mostly nitrogen. It doesn't really hurt us, but we breathe in mostly nitrogen. We breathe in a little bit of carbon dioxide, a little bit of water vapor, and some other gases. Oh, this is carbon dioxide. So most of these don't hurt us. Oxygen helps us, but actually most of it is nitrogen and it really does nothing. So here's a question for you. If I cut a water molecule, what would it be? A, 2 water molecules, still water. B, 1 oxygen atom and 2 hydrogen atoms, not water anymore. C, 1 proton and 2 neutrons, not water anymore. Or D, none of the above. Write your answer in your notebook. Go ahead and pause. Okay, the correct answer is B. It is no longer water if you cut it. It could be C, but it would be a lot more protons and a lot more neutrons. So B is the better answer. Try and come up with a good definition of molecule with your neighbor or just in your notebook. Go ahead and pause it. All right, here are the ones I came up with. A molecule is a group of atoms, so the smaller ones, bonded together to make its own substance. Or you could also say the smallest form of matter that a certain substance can be. Well, I like this one, the second one better. So a water molecule cannot get any smaller or it's not water anymore. So this is a water molecule. If I tried to cut this, I would either be breaking it apart like this, where I have oxygen and 2 hydrogens separated, but not together. So this isn't water. Or I'd split it in half like this, and this would be H1O half instead of H2O. This isn't possible, but that's because you can't cut water in half. You could cut it into thirds like that, but it's not water anymore if you cut it. Go ahead and write down or make a tip chart for the word molecule. Write molecule here, the definition here in your own words, and then draw a picture. Go ahead and pause it. All right, make sure you add this to your index with the correct page number. All right, when I talk about air, I'm talking about any air molecules. So water, nitrogen, oxygen, carbon dioxide, I'm talking about all of it. It's mostly made out of nitrogen, but this would be complicated to draw every time. So when I talk about air molecules, I'll probably just draw it like this, just little circles. So when I'm drawing this is what it actually looks like, but this is what I'm going to draw. All right. Pressure is a special thing. It's kind of like force. It's how hard something pushes on a surface, on a certain surface size, a certain area. So the atmosphere pushes on every square inch with about 14 pounds of force. That means if you took a little square inch, there's 14 pounds of force from the atmosphere on it. So here's a question for you, little math question. If every square inch of you has 14 pounds pushing on it, and your head and shoulders are about 16 inches squared, how hard is the air above you pushing on you, your head and your shoulders? Write your answer in your notebook. Go ahead and pause. All right, for some of you, this may have been a difficult question. It's really just multiplication. 14 times 60 is 840 pounds. Yes, 840 pounds. So you have like a refrigerator sitting on top of your head right now, just in air. You don't feel it because your body's used to it. Now, it's not just pushing down on your head. It's also pushing on the sides of your head. And it's also pushing in every single direction. But the other good thing is inside of your body, you also have air, which is pushing back on it. So you really don't feel it. Okay, so you have air inside of your head, and outside of your head, there's a lot of pressure pushing this down. But there's enough air inside of your head and your body that it pushes back, and it doesn't let your head get squished. This is a good thing. Okay, so air makes pressure. Molecules don't like to get close together, and when they get too close, they push back. So we're eventually going to get to this when there's a difference in pressure. Nature does not like it when there's a difference in pressure. And you'll see that in a couple demonstrations we'll do. But you may have also heard that when you go into space, you explode. This is because there's no pressure in space. So all of the air inside of your body would immediately try and get out into space. So you would explode. That's where that idea comes from. All right. So the number of molecules in an area affects the pressure. If there are more molecules, there is more pressure. If there are less molecules, there is less pressure. Okay, and here's what would happen. Where there's high pressure, the high pressure would try to get to the low pressure. These molecules would try and jump over here because nature doesn't like it when there's a difference. So it tries to jump over here. If you were standing right here, you would feel wind. The air molecules would be moving across this way. So you would feel a wind. All right. Hopefully this isn't too difficult. Which box has a higher pressure? Go ahead and pause it. Correct answer is A. A has a higher pressure because it has more molecules in it. I hope that wasn't too difficult. Okay. Now, these two boxes have the same number of molecules. They both have 1, 2, 3, 6, 7, 8. 8 molecules in them. However, one of these has molecules that are moving faster. Molecules that are moving fast are hot. So these are hot molecules, these are cold. All right. So what you would see is this would be a higher pressure. The faster the molecules are moving, the higher the pressure. Okay, so these would be bumping into each other faster. These wouldn't be bumping into each other as much. Draw a box that have hot molecules and cold molecules. You use the arrows to show the speed, please. This is just to get you practice drawing what hot and cold looks like. Go ahead and pause it. All right. You should have drawn something like this. Doesn't have to look exactly like this, but something similar. Longer arrows mean fast, or bigger arrows mean fast, and smaller arrows mean slow and cold. All right, which box has a higher pressure? Hopefully you were listening. Write your answer in your notebook. Go ahead and pause it. All right. Which box has a higher pressure? The correct answer is A. These molecules are moving faster, so they have a higher pressure. All right. Last thing you need to do for this video, you need to draw two boxes. One box has high pressure, and one box has low pressure. You can choose to do that with temperature or with number of molecules. I'll leave that up to you. That's it for this video. So what I need you to do is go to Google Classrooms and answer the questions about this video. That's it on air pressure. I'll see you next time.